we are continuing our study on sequences and series by discussing geometric sequences. Now, who can remind me what an arithmetic sequence, how we identify that? Seth?
It's something where the sequence goes up by a certain number every time.
So what did we call it? We said it was a common difference, right? A common change, that is addition or subtraction, so it's a common difference, either positive or negative. So if I look here at options A, B, and C, do we see any of those having a common or a consistent difference every time I change terms? No. Because on A, if I start thinking about it, I went up by 3. If I keep doing the same thing, my next term should be 9. That doesn't work out. B, I actually go down. And we can quickly identify, based off the sequence that we see there, well, there's not a common difference because my values keep getting much smaller, but there is a common ratio. And in C, I'm alternating positive, negative, which we can do, which is still a sequence, but it's definitely not arithmetic. That wouldn't make any sense if I said I was adding the same thing every time and I end up alternating positive, negatives. That wouldn't make any sense. So all three of these are examples of geometric sequences. So if we look at A, what do we think the common change or the common difference in A is? Yeah, go ahead.
1, I think you mean common ratio, and 2.
There we go, yeah. Well, the common change is that we're doubling, so then we have to call it a common ratio. So our ratio there, and I don't know why every time you guys come in, my smartboard gets screwed up. Maybe it's just
Greg's fault. Greg's fault.
Somebody poking my head. Hello. All right, Greg, you had your hand up. Do you know the common ratio for B? How are we getting from one term to the next term to the next term?
Isn't it like times 0.1?
Yeah, which we can say either times 0.1 or 1/10. And in C, well, we know that since we're alternating positive, negative, we have to multiply by a negative. How do I get from 1/3 to 1/9 or 1/9 to 1/27? Robert? Yeah, it'll be the negative 1/3. So there are 3 examples of geometric sequences that we can identify by saying we are multiplying by something over and over and over to get the terms in that sequence.
In this problem,
So we have to identify now our things, and actually just to speed up, let's come over to here. Huh? Sorry, go ahead.
Why'd you write like an X for times?
Yeah, I know. Then I realized I really shouldn't because we don't. Okay, you're allowed to still use it, but we just don't like to. Because we use X as the variable now, we don't like using it for multiply. So I know I wrote it for the first one, then I decided to change.
Why ever teach last year?
I agree. Why ever teach it if we're then going to say stop using it? I agree.
I have to teach 4th grade sometimes and they're so confused when they should not
Because if we taught it initially, they would get confused between the decimal point and the multiplication. That's why to start, they make those different. Then, yeah. I know. I agree. So, geometric sequences. Who can remind me what recursive means? If a sequence is recursive, it uses, Liam? It uses a previous term. So, if a geometric sequence is recursive, then I'm going to write it using its previous term times r, that common ratio. If it's explicit, not as in that explicit album, but explicit meaning clearly stated, we're going to have our first term times our common ratio to the power of whatever term I'm at minus 1. Because my first term did not multiply by that ratio yet, that's why we have the n minus 1 there. And a lot of times, I could write a recursive or an explicit definition depending on which I'm being asked to write. So in number 1, when we look at A, we see, okay, 3, 6, 12, 24, 48. We can check it by setting up ratio comparisons of one term to its next term. So we have shown out here in your notes, take your bigger term divided by your smaller term, keep doing that over and over and over, and if they all come out to be the same value, you know that's your common ratio. So our sequence, we could just say a sub 1 is 3. My common ratio is 2. Pretty straightforward. So we look at B. Is this geometric? 3, 6, 9, 12, 15. No. What is it doing?
Adding.
It's adding 3 every time. So actually this, not geometric, it's arithmetic. Now what if in a sequence I see power comparisons? So I see 3 to the 5th, then 3 to the 10th, then 3 to the 15th, then 3 to the 20th. Seth?
Is geometric, isn't it?
Don't ask me, I'm asking.
When you
If it's geometric, what would the common ratio be?
3 to the 5th.
Okay, so if we took 3 to the 5th times 3 to the 5th, what would we get?
3 to the 10th.
3 to the 10th, why?
Because
Because when we're multiplying, the powers actually add. So then again, if I multiply by 3 to the 5th, the powers add, and I get 3 to the 15th. So yes, this is geometric, and my ratio is actually 3 to the 5th, which we could evaluate, and we could write that out in its simplest, like just with the number. Or we can just leave it like this, because it makes it nice and easy for me to see. Good catch there.
Oh, I got one.
You got it?
It's R equals 2.
Yep. So a sub 1 is 2 and r equals 2. And it wanted us to identify our a sub 1's up here, but okay, 3 and 3 to the 5th. Any questions? Didn't think so. Okay, so now when we gotta find the nth term, here n being 10, we're asked for the 10th term. It says a sub 1 is 4, the common ratio is 3. So how could we write this out? Well, we can use the explicit or the recursive. The explicit is easier to work with because it doesn't use that a sub n minus 1. That gets kind of annoying. So I here can say a sub n. Well, what was my first term? 4 times, what's the ratio? 3 to the n minus 1. So then when we want to say a sub 10, well, that's going to be 4 times 3 to 10 minus 1. Come on, smartboard, just cooperate. And that's 4 times 3 to the 9th. And then we simplify. 3 to the 9th, then multiply by 4. We are going to get that a sub 10 is a very large value. 78,732. Little bonus question here. If you think about graphing a geometric sequence, what sort of graph would that end up being? Exponential, right? Anytime we're multiplying by a common factor, anytime we see a common ratio from one term to the next, we know that's going to end up looking exponential. So your first term is 2. The fourth term, a sub 4, is negative 54. How do we figure out what my second and my third terms could be? Well, what do we know automatically since you see the first and the fourth term? Jacob?
the ratio, the common ratio is a integer and it's also negative.
Common ratio is going to be negative. How do you know that it's an integer?
Because if it was less than 1 and it was like the fraction, then the values would be decreased.
I mean, we can have integers bigger than 1, though. Remember, integers mean entire values. You could have like 2.5. That would not be an integer. but it'd get my values bigger.
Okay, so it has to be above 1.
Yeah, it has to be over 1, but it has to be negative. Now, I will agree that it has to be an integer because I multiplied by the same thing twice and then still got an integer value. But it's all like, well, how do we know that? Why do we reason there? So I can look at this and I can compare a sub 1. I can compare a sub 4. What Jacob has told me so far is my ratio is negative and it's going to be a value larger than 1. So larger, of course, relative to the fact that we're negative. What do you think? All you have to do is set up. Okay, go ahead. Leon.
Like 2x squared equals negative 54. 2x?
No, it would be 2x cubed.
Yeah, 2x cubed.
So, set up your explicit formula, then we'll plug in what we know. My explicit formula, that's why we start, that's why I gave it to you on your paper. Set it up, plug in everything we know. So next below here, everybody needs to replace a sub 4 with negative 54. So I should see people writing. We're going to replace that. Then what can I do to help simplify and work towards getting r by itself? If I have 2 times r to the third, Seth?
Divide both sides by 2.
Divide by 2. So real easy, get rid of the 2. I get negative 27 equals r to the third. What do I do to get rid of something to the third? Cube root. So if I cube root, negative 3. But I'm not done because I need to solve for the second and third terms here. So now that I know my ratio, what's going to be my second term? Negative 6. What's going to be my third term? 18. Any questions on what we did there? Set up your explicit, plug in everything you know, solve it for what you don't know. No issues. Try, you got it. Even if you can figure it out in your head, try your got it using the method where we write out our formula and solve it. So you know your first term and then you know your third term. I'm actually going to work above here. Hopefully you're able to do this on your own, not just looking and following what I'm doing. What would be my next step? Robert? Plug in the what?
Plug in from your a sub 3.
Yeah, so I already plugged in my 3 for my a sub 1. So I scoot this over to show exactly what I'm doing. So then I can plug in my 12 for my a sub 3. I can do my 3 minus 1. I can go ahead and change that just to a square. Now I want to divide by 3, showing me that r squared is 12 divided by 3, 4, which then when I square root, we get that r is 2. So then my second term here, how do we know it's not negative?
Because it would have to be squared in order for it to.
Robert?
Because also none of your values are negative.
We don't. Well, because like
It could be.
it would be like for the third term it would be squared, and it wouldn't.
Greg, why'd you say we don't?
Because there's like. I don't know. I actually know. Because it's like every other. It could be negative and positive.
We don't know that this r is actually 2, because think about it. Radical 4 has 2 answers. All square roots have 2 answers. So my ratio is actually positive or negative 2, which means that this value is either positive or negative 6. I don't know until I know something else, until I see a 4th or a 6th or some kind of even term. Because right now all we have is the odd terms. I have the first term and the third term. I'm not certain whether my ratio needs to be positive or negative. So that's the problem when they only tell you 2 pieces of information and they're both odd terms or both even terms. We're still missing some information. So we have 2 possible answers here. Could be positive or negative 6. Does that make sense why we don't actually know here? Because this would be negative, then this could be negative. And yeah, we just don't know. So this is when we really start talking about these things. And you guys probably remember the lab you did last year from Mr. Cabilo with the golf ball. Now the problem with a golf ball is it's got... Actually, what's the problem with a golf ball? Well, they're not hexagons. They're actually circles. They're divots. Or dimples is sometimes what they call them. What's the issue with the dimples? They change the way it bounces. So when you drop a golf ball, you're not going to get a perfect model like this unless you somehow make sure it drops perfectly. So when we're talking about models like this, we're talking like a ping pong ball or something that's perfectly spherical. So when a ball bounces, the heights of consecutive bounces form a geometric sequence because it's going to be changing or losing the same amount every time because it's working against gravity, air resistance, all that sort of stuff. So we see... and check out the reasoning down below here. We want to find the 4th and 5th bounces. This is my first, this is bounce 1 because we started here. So bounce 1, this is height of bounce 1, height of bounce 2, height of bounce 3, height of bounce 4. How can we figure out what that ratio is? Do what? Setting up our explicit formula with what we know. So I know that my general form of my explicit formula, a sub n equals a sub 1 times r to the n minus 1. I know my a sub 3 and I know my a sub 1. We cannot use our a sub 1 here because then it won't tell me my ratio because anything to the 0 power is 1, so it won't really do anything for me. So I use my a sub 3, plug in that my first bounce was 100. This is going to be 3 minus 1. I also know that a sub 3, I'm going to leave it written up here, and then, but if you jump straight to this, that's okay. Not wonderful, but okay. This gets a little tricky. What would I do now? Seth?
Divide both sides by 100.
Divide by 100. Do not actually perform the division. Just write it. Because now what we see is r squared is 49 over 100. Again, don't actually do this yet. What do I do to get r by itself? What happens when I square root a fraction? I square root the numerator and I square root the denominator both separately. Square root of 49. Square root of 100. It's easier. Not saying it's better, but it's easier when we just leave it as a fraction and figure out our ratio that way. So what we see is that because of gravity, and I don't know exactly what type of ball this is, but because of gravity and the recoil of that ball, every time we bounce, we're doing what?
Taking 70%.
No, taking.
Yeah.
He saved it with what he said at the end there. I think Grant thought you were going to say taking 70% away.
Yeah.
So what were you, if you said taking, what were you going to say? Yeah. So what we see is we find or we have or we end up with 70% of the previous bounce or the previous height. So every new height is going to be 70%. But again, we're still not done. We need to find our fourth and fifth bounces. So set up our explicit formula for the fourth and fifth terms. So now that I know my ratio, I'm going to clear all this out and say, all right, a sub 4, you will be that 100 times 0.7 to the power of 4 minus 1. Really 0.7 to the third power.
0.243.
It'd be 0.49 times 0.7, so. Yep, 343.
Oh,
I didn't hear if you said 2 or 3. So that times 100. And we get our fourth bounce. We'll be at a height of 34.3 centimeters. Stupid smartboard. Yeah, I'm not trying to be funny. It's just getting more and more frustrating. And a sub 5. What's a quick way to get to my a sub 5? What would be a quicker way to get to my a sub 5 now? Sasha? Yeah, just take your a sub 4 and multiply by 0.7 again. So without even doing all this work, I'm going to just multiply the last bounce by 0.7, and I find out 24.01 centimeters for bounce 5. Any questions on what we just did? Would there ever be a situation where your bounce could be higher than the initial? Greg?
if you like threw it.
Okay, if you threw it, if you had more initial velocity, so if it wasn't just dropped. Beth?
If it left some of it behind when it hit the ground.
Ooh, that's an interesting case. If it left some of it behind when it hit the ground.
If it was thrown at escape velocity.
Okay, so if there was an initial velocity, or go to a different planet. If you didn't have as much gravity to pull it back down, but then the issue becomes you don't have enough gravity to start with, because this gets its bounce from gravity pulling it down. So when you get deeper into physics, I'm just trying to like give you a taste of it. When you get deeper into physics, you look at those situations of like, is there ever a possibility that we could make a ball bounce forever? Like, could we figure out the math to make that happen? Or could we make a ball continuously bounce higher than it had before? And then that gets really weird. Okay, so just giving you a little taste, that's where you head with some of this stuff. What are the possible values of the missing term of the geometric sequence here? Well, again, we're finding geometric mean. So we know that because it's in an exponential model, we're going to use roots. Oh, I think we pretty much talked about all this. Oh, to find the height of the 10th bounce.
You could use both, right?
Yeah, we could use both. Let's see what happens. So real quick up here, if we do my a sub 10, if I use my recursive, if I use my explicit, that will be the 100 times 0.7 to the 10 minus 1. .7 to the 9th. We'd get about 4.03. Actually rounded it would be 4. And we could use recursive, but again, recursive is kind of annoying.
Yeah, have to solve for everything.
I think
Yeah.
this is explicit is just
Explicit is always easier. So last thing to talk about is when you're looking for the geometric mean and you have both terms that are beside it, you multiply the terms together, take the square root of them. So you want to have this formula circled, highlighted, starred, something like that. So to do this, 48 times 3 is 144. What's radical 144? 12 or negative 12. because I only see the first and the third term here, I only see odd terms, so I'm not certain whether this ratio will be a positive or negative. So if this value is 12 or negative 12, what is your ratio? What's your ratio? Ooh, no, it's not.
Plus minus 1/4.
Okay. Positive or negative. Don't say plus minus. Positive or negative. 1/4. My values are getting smaller. So although the relationship involves 4, it's not 4, it's 1/4.
I was like going from like this.
I know, you were going right to left, and we can't. We got to go left to right. All right, that's it. I like what you did there, Grant. Again, we're on the K form because the G form had like 57 questions.
I just buy like one foods.
You know what would make you really awesome?
I'm just gonna go there and say it. It's like every few days.
Each row is 25, I believe.
Yeah, I'm exactly 28. I just get putting a couch in.
So we have about 15 minutes left. If anyone needs to finish masteries or anything like that.